You know, when you see an electric car whoosh by or a massive wind turbine spinning on the horizon, you're looking at our green future, right? But have you ever wondered what's inside them? What's the secret sauce making all that tech work? Well, it turns out it's this special group of minerals, these hidden ingredients that are literally shaping our clean energy world.
So these things are called rare earth elements, or REEs for short. And honestly, they're in everything. Just take a look at this chart. That huge slice, almost half, is for magnets. And no, we're not talking about the ones holding up your art on the fridge. We're talking about incredibly powerful, high-tech magnets. They're the absolute heart of an EV motor. They're what makes a wind turbine spin. They are, and I'm not exaggerating here, what makes the green revolution actually go round.
Okay, so what are these things really? Well, rare earth elements aren't just one thing. It's actually a family of 17 different metallic elements. A good way to think about them is like a chef's spice rack. Each one has a very specific, almost magical property. It's their unique magnetic and glowy, or phosphorescent qualities that make our phone screens light up and our electric motors so incredibly efficient. You just can't build this stuff without them. They're totally essential.
All right, but here's where things get a little weird. It's a huge paradox, actually. See, despite the name rare earths, they're not actually rare. Some of them are more common in the Earth's crust than copper or even lead. So why the name? The rarity isn't about how much is out there. It's about how hard they are to get. They're scattered all over the place, and finding a spot where they're concentrated enough to mine is the real challenge. And then, separating them from each other, that's another nightmare altogether.
And the scale of this whole challenge is just massive. You have to understand, this move to net zero energy, it's basically a mineral guzzling process. To hit our Paris Agreement goals, we're going to need 4 times the amount of these minerals by 2040. Let that sink in, a 400% increase. So the big takeaway here is pretty stark. Our clean, green future is literally built on a foundation of digging stuff out of the ground. A lot of stuff. Okay, so that brings us to the first giant hurdle we have to face, the supply chain. It is shockingly fragile. The whole journey from a chunk of rock in the ground to a finished high-tech component is concentrated in just a few places, and that creates massive geopolitical risks for pretty much every single country on the planet.
And if you want a number that should really make you sit up and pay attention, here it is, 90%. One country, China, controls a staggering 90% of the processing and smelting for these elements. And notice I said processing, not mining. Mining is the relatively easy part. It's the super complex, high-value step of turning that raw dirt into pure, usable metals. And one country has a near-total monopoly on it.
This map just lays it all out, plain and simple. You've got mines in Australia, the US, Africa. They're all digging up the raw ore. But then what happens? Look at the lines. They almost all funnel to one place for that supercritical cracking and separation I was talking about. It's a textbook example of global dependency on a single hub.
So what's the big deal? What does this actually mean for a country? Well, check out this chart. It's the UK's official criticality assessment. And you see rare earths way up there in the top right? That's the red zone, the danger zone. It means 2 things. The supply is super risky, and they're absolutely vital for the economy. So yeah, this isn't some abstract issue for economists to debate. It's a very real national security and economic weakness.
But believe it or not, that huge supply chain risk is only half the story. We've got another major problem to talk about, and that's the dirty secret behind all this green tech. Getting these elements out of the ground and into our gadgets is a messy, complicated, and frankly, an environmentally nasty business.
I mean, the journey from a simple rock to a pure, usable element is an absolute industrial marathon. It's not just digging. First you mine the ore, then you crush it into powder. But then comes the really gnarly part they call cracking. This involves using vats of hot corrosive acid to basically dissolve the minerals into this chemical soup. After that, you have to do this incredibly painstaking separation process, kind of like chemical dialysis, to pull out each of the 17 different elements one by one. And that whole process creates this really jarring visual, doesn't it? On the one hand, you've got the whole reason we're doing this: clean, green energy, a healthy planet. But on the other hand, the reality of producing the stuff for it can look, it can look like this, a long way from a pristine forest, right?
Yeah, the environmental footprint here it's pretty big. For starters, the ores themselves often have radioactive elements mixed in, like thorium and uranium, and that stuff ends up in the waste. The process also uses a mind-boggling amount of water. We're talking over 17 million cubic meters in just 1 year.
On top of that, it's a huge energy hog, and the chemicals involved, they can leak into groundwater and even cause things like landslides. It's serious stuff.
Okay, I know this all sounds pretty grim, but it is not all bad news. In fact, far from it. The really cool part is that all these massive challenges are forcing us to get smart. It sparked this incredible wave of innovation. Right now, scientists and engineers all over the world are in this race to figure out cleaner, smarter, and way more sustainable ways to get these elements.
So what's the plan? How are we getting smarter? This chart kind of says it all. The old way, it's all about brute force, roasting things at high temperatures, dumping in tons of chemicals. The new way, it's about being precise. It's about biology. So instead of just heating everything, we're using smart sensors to sort the good stuff from the bad. And get this, instead of harsh acids, some people are using actual microbes, tiny living organisms, to do the chemical heavy lifting. It's called bioleaching, and it's a total game changer.
And here's what that actually looks like in the real world. This machine is a smart sorter. So imagine crushed rock flying by on a conveyor belt. This thing uses X-rays to scan every single piece in milliseconds. It spots the rocks that actually have the valuable minerals and bam, hits them with a precise puff of air to knock them into a separate bin. Think about it. By doing that right at the beginning, you don't have to waste all that energy and water grinding and processing tons of useless rock. It's genius. But maybe the most exciting idea of all is that we can start mining our own waste. We're literally going back to the giant piles of waste from old mines, the tailings, and pulling the rare earths out of them. We can even extract them from acidic water draining out of mines. And those microbes I mentioned, they can literally eat rock and spit out the good stuff. This is the start of a real circular economy for these minerals, and that's huge. Now, all these cool tech solutions are absolutely critical, but they're not enough on their own. They have to fit into a much bigger picture, a whole new global strategy. And the good news is, countries are finally waking up to the risks. They're starting to actively plan for a future where the supply chain for these resources is much more resilient and much more responsible.
And this is pretty much the blueprint that nations are starting to use. So what's on it? First, build partnerships with different countries so you're not relying on just one. Second, bring some of that processing back home with incentives to shorten those crazy long supply chains. Third, create something like a fair trade sticker for minerals so you know they're sourced ethically. Fourth, this idea of full value mining. Don't just pull out one metal, get everything valuable out of that rock. And of course, you've got to fund the research to make all this happen.
But, it's never quite that simple. There are always complications. Take that fair trade idea. As this quote points out, if you create a premium, ethically sourced supply chain, well, those materials are going to cost more. And anytime something costs more, you create an incentive for people to cheat the system and forge the certificates. So what this tells us is that a piece of paper isn't enough. We're going to need real science, like geoforensic fingerprinting, to actually prove where a mineral came from.
So, all of this brings us back to the biggest question of all, doesn't it? Our whole green future depends on these hidden ingredients. But the real challenge, the real test, isn't just about building a better electric car. It's about building a supply chain that's as clean and sustainable as the technologies it enables. It's a tough paradox, right? To build a green world, we first have to get our hands dirty. The question we all have to answer is, can we do it without compromising the very ideals we're trying to achieve?